So, in lesson 3 of chapter 7, we are now talking about rational exponents. Lesson 1, we just did regular exponents. Lesson 2, we did negative exponents. Lesson 3, rational. That means can be written as a ratio or aka a fraction. Yes, fractional exponents. Okay, so because we've multiplied the powers with the same base and we've raised powers to powers, I want to start off with this example right here. So I know that's a fractional exponent, b to the 1/2 to the second power. Well, when we multiply, and they show here 1/2 and 1/2, and we add exponents, well, that'd be 1. Also, I could say multiplying exponents, what's 1/2 times 2? That is indeed 1b, which tells me that the 1/2 exponent and the 2 exponent are inverse operations. They actually undo one another. So if I think about that, this right here is the same as the square root of b, because hopefully you remember that if I take the square root of something and then square it, I will end up being there. So the 1/2 exponent is really the square root. Take a look at these examples. So the 1/2, 16 to the 1/2 power is really the square root of 16, which is 4. 38 to the 1/2 power is really the square root of 38, which is just the square root of 38. We cannot reduce that because 38 is not a perfect square, and also there are no perfect square factors of 38. So like 4 doesn't go into that, 25 doesn't go into that, 9 doesn't go into that, so we cannot reduce that. All right, so take a look. First problem, we are just simply simplifying. Well, they want to write them in radical form, so as a root. So square root of 18 is just the square, or 18 to the 1/2 power is the square root of 18. And I know 18 is not a perfect square, but I do know that 18 consists of 9 times 2, and because 9 is a perfect square, I can take the square root of 9 and the square root of 2, that is the same thing, and the square root of 9 is indeed 3. So the answer is 3 square root of 2. And if you've taken course 3, you've simplified radicals before. If you have not, that is kind of new, which is why I went through it step by step. Okay, letter B, so right below it is the square root of 31. So it is a radical. We want to write it in exponential form, so that is the square root, which would be 31 to the 1/2 power. That's it. Okay, this one is to the 1/2 power. Notice, is the 6 to the 1/2 power? No, it's not, because they didn't put it in parentheses. So it's 6 times the square root of a. That's your answer. All right, and then letter D is 3 square root of 5c, and so this is to the 1/2 power. And I would let you just leave it like that. All right, so moving on, what if we're taking these into fractions and so on? Well, they're roots, so we have to remember. So if it's the 4th root, that is to the 1/4 power. Or, in other words, what times itself 4 times is 625. And if you might have a pretty good guess. And that one I feel like should be an automatic. It is indeed 5 times 5 times 5 times 5. There are 4 of them. So your answer is 5, the 4th root. Because if there are 4 of them, you get to take it out. Okay? Same thing, the cubed root of 216. Well, I know that 216 is a factor of 6, actually, and it is 6 times 6 times 6. So the cubed root of 6 times 6 times 6, since there's 1, 2, 3 of them, the 3rd root, that is what you can take out. All right, and C is even easier, or hopefully you're pretty familiar with the cubed root of 27 and the cubed root of 64. That's what it is when we have a root. We just take the root of both of them. So it is just 3/4. All right. Now flip that page over. We are going to continue to get complicated. All right. They're going to put it as a exponent, fractional exponent or a rational exponent, and ask you to simplify it. So you need to remember that a fractional exponent is really just a root of whatever the denominator is. So in example A, 343 to the 1/3 power is really just the third root of 343, and I'm not sure you can identify that, but it's going to be, there is a number that goes in there perfectly 3 times, and it is 7. And some of you are going to just know that, and some of you are just going to have to plug and chug and make guesses. All right, so that would be 7. All right, and 243 to the 1/5, so it's the 5th root. Some number times itself 5 times over is 243. And if there are any guesses, this number should give you a hint. There's only so many numbers that give you a 3. And it's only 243, which is smaller than 343 to the 3rd power, so it's got to be smaller than 7. And if you've guessed enough, you will know that it is 3. And a lot of that is just my number sense. I'm familiar with those numbers because I've worked with powers long enough, and you'll get there too. And some of you maybe already are, so that's fantastic. All right, so what happens when we have a fraction exponent that doesn't have a 1 in the numerator? Well, whatever the denominator fraction is, that's the root you're taking, and then you simply take it to the power of the numerator when you're done. So take a look at this example. 8 to the 2/3. 3 in the denominator means I'm taking the cubed root of 8, and then I'm going to square it. Cubed root of 8 is 2, because 2 times 2 times 2 is 8, and then 2 squared is 4. So let's see what that looks like in a few examples. All right, we have 16 to the 3/4. Well, because 4 is the denominator, it is the 4th root of 16, and then once we get that answer, we will cube it, because that is our numerator. All right, hopefully you're pretty familiar with 16. What number goes into 16 4 times over? Should be 2, because 2 times 2 times 2 times 2 is indeed 16. And then when we cube the 2, we will get 8. All right, over here in letter B, same type of problem here, 27 to the 5/3 power. That's a cubed root of 27, and hopefully we know that. And then after we do the cubed root, we are going to take it to the 5th power. And so the cubed root of 27 is 3, and 3 to the 5th power, you may use your calculator, is going to be 243. I didn't have to, because guess what? We just talked about that one up there. Okay. Taking to page 3, it's going to continue to get complicated. Now we are going to write an expression that includes that. So take a look at this. I have 4 to some power is 1024. Okay, so how do I undo an exponent multiplied by its reciprocal? So otherwise, I just think 4 to the what power? 4 times 4 times 4, just take a guess, figure it out. Okay, well, what's going to give me 1024? 4 times 4 is only 16, times 4 is 64, times 4 is, I believe, 256. So, and then times 4 is going to be 1024. So 1, 2, 3, 4, 5. So guess what? Y equals 5. All right, B is a little more complicated, because take a look at that. I got 36 to the some exponent gives me 216. Well, guess what? 36 squared is bigger than 216. So I know that's going to be a fractional exponent. So, any ideas what we're going to do here? And I'll tell you, it has something to do with these two. We need to write 36 and 216 as powers of the same base. Now 36, hopefully we know, is 6 squared. And 216 is 6 to the third. Now when we raise a power to a power, what do we do with our exponents? We multiply them. Now I have a binomial, so I actually have to distribute that too. So it's 6 to the 2x plus 4 equals 6 cubed. Well, if 6 to the some exponent equals 6 to some exponent, what do we know about these two exponents? They better be equal. So 2x plus 4 has to equal 3. And now I have a two-step equation. Subtract 4, divide by 2, x is negative 1/2. And you guys can't see that, sorry about that. So we're taking all of the rules that we know from our exponents, and we are using them to calculate my missing variable. All right, take a look at this word problem. You're going to see problems like that. You really want to think about that one a lot. That one's going to come up in your homework quite a bit. Okay, so let's do exponential equations. Okay, the population of a specific species of insect is modeled by this equation. Population equals 30 times d to the 2/5 power, where p is the population, I already said that, of the colony, and d is the number of days. So d stands for days after the colony is formed. How many days will the colony have a population of 300? So we're finding d, but they gave us p. So I'm going to take that equation, p equals 30d to the 2/5 power, and p is 300. Oops, 2/5 power. First thing I'm going to do is divide by 30. So I get d to the 2/5 power is 10. Okay, now, this is a little goofy, but I want to know what d is. How can I get rid of that fraction? I am going to raise it to the reciprocal power, because the reciprocal power will make this, when I multiply these two, 1. So d equals 10 to the 5/2. Or d equals 10 to the 5th, excuse me, the square root of 10 to the 5th power. And there you have it. Either of those will work for an answer. Well, that doesn't make a lot of sense now, does it? Because I need to find out days. So, any guess is what we're going to do there. This is the square root of 10 times the square root of 10, square root of 10, square root of 10, square root of 10. And these two give me 10, and these two give me 10, and this one leaves me square root. And I'm multiplying, so 100 times the square root of 10. And the square root of 10 is approximately 100 times 3.16. What is it? Does it say? It doesn't say. So 316, approximately 316 days. So I guess once you're here, you can probably just use your calculator. All right. right, here's a new one. Population of a culture that begins with 40 bacteria and doubles every 8 hours can be modeled by P equals 42 to the T over 8th power, where T is time in hours. Find T if P is 20,480. So I've got 20,480 equals 40, 2 to the T over 8 power. I am going to divide by 4. So 20,480 divided by 4, I should be able to do that in my head, but I just want to double check, is 5,120 equals 2 to the T over 8 power. So I am going to get rid of my denominator in my fractional exponent by raising everything to the 8th power, because when I raise it to the 8th power, when I multiply this times this, the 8's cancel. So I'm not going to actually multiply that out. I'm going to leave it 5,120 to the 8th power equals 2 to the T power. Why would I leave it? Well, because I know this is 2 to some power. So let me ask you, what do you think? Do we think 2 to a power will give me this? All right, let's break it down. Let's divide this by 2. 5,120 divided by 2. So 2 to the what power? And I know that 2 to the 5th is 32, 2 to the 6th is 64, and I'm doing this on my calculator here. So 2 to the, 8th, 256. 2 to the 10th, how about 2 to the 12th? I have to go back to my notes. Oh, that helps. Oh, you guys, you didn't help me out. See, this is what helps when I'm live. So I should have been dividing by 40, which would give me 512. Okay, so if you are following along and kind of just blindly following me, I apologize. It was a 40, not a 4. Take a look right here. So when I divide by 40, instead of 5,120, I should have 512, which makes it a much better problem. That's why I was stumped. I already did this problem once, and I thought it worked out. So it's 512 is 2 to what power? 2 to the what power? 512 is 2 to the 9th power, and I found that out by simply plugging and going and checking. Now when I raise a power to a power, I multiply, so this is 2 to the 72nd and 2 to the T, which means T equals 72 hours. Sorry about that, you guys. Hopefully I didn't completely screw you up. All right, okay, last one here. Chemistry. The radius of a nucleus of an atom is A. Radius equals 1.2 A to the 1/3 femtometers. Wow, that's an interesting word. Can't even tell you what that means. So find A if R is 3.6. So then I have this equation. R equals 1.2 A to the 1/3 power. Okay, and if R is 3.6 equals 1.2 A to the 1/3 power. First thing I'm going to do is divide by 1.2. Hey, I got this one right. And I'm going to get 3 over here equals A to the 1/3 power. Well, a to the 1/3 power is the same as the cubed root of something. What something gives me the cubed root? Okay, well, how do I undo that? I can just raise everything to this reciprocal to cancel that out. So if I raise 3 to the 3rd power, that's 27. And 1/3 to the 3rd power, those two cancel out. So your area is 27. And it's actually going to be 27 femtometers squared. Equals A. Crazy. Okay, so I hope we figured this out, and I'm always around for asking questions, and I know I screwed up that biology one. I apologize. Good luck. Your assignment is on the back of your sheet, and it should be 18 through 44 even. We are going to continue this lesson again tomorrow. And do more word problems tomorrow. So if you didn't get all the word problems, it's okay. Hang in there. We'll do some more of those tomorrow. Okay?